we can conveniently choose a radial vector from a pivot point that's perpendicular to the line of action of a force. So recalling that the torque is the cross product between R and F, and the magnitude is RF sine theta. Well, in this case, the radial vector from the pivot point is perpendicular to the line of action of the force, so theta is pi on 2. And therefore the magnitude of the torque is simply RF. So in this case, R is the moment arm, which is the distance between the pivot point and the line of action of the force. So this is useful, for example, where we have this socket wrench and we're trying to tighten a bolt. So this is our pivot point, and we apply a force on the wrench and draw a vector from the pivot point to the line of action of the force. So in this case, if you use the right hand rule, this force is going to produce a clockwise torque about the pivot point to tighten that bolt, and therefore the torque vector points inside the screen. So this can be seen if you place the force vector at the tail of the radial vector, and then use your right hand and curl your fingers from R to the force vector. And your thumb is going to point inside the screen. So in this case, the magnitude of the torque is simply R by F.